Okay. So the first question here is 1987.3. It says the velocity time graph below describe the motion of a particle between 2 points P and Q. What is the distance between P and Q? Funnily enough, I can't even say graph properly. But I know this velocity is fine. Wow. Let's see the graph. Where is PSQ? Okay. Let's see the 1978 question, question 3. Let's check 1987. So the issue is that I don't even know where P is and where Q is. But nonetheless, I'll do something that's so if you accept question number 1, I'll just put a line here. So I don't know where P and I don't know where Q is. Because the question is not showing us P and Q. No. Okay. So I want to look at it in this regard. That we have something like this, something like this, something like this, and something like this. Let me guess that's what I'm doing. Just to guess. So I'm guessing that this is P and this is Q. I can't get the question clear. But you guys will not have something like this. You don't be straight. To be very clear, you have to be very clear. So this is the motion, this is the line. So, so if you see that this one is a straight line graph, then this one here is a rectangle. This one here is a triangle. And let's say that this is the trapezium. This is a triangle, a straight triangle. Hmm? So the area of this triangle is distance covered. That was what I forgot to mention. Area of the shape formed in a velocity time graph is equal to distance covered. Now, I'm going to label this A, B, C, and D. Shape A is a triangle. Shape B is a trapezium. Shape C is a rectangle. And shape D is a triangle. So we're going to find the area of these three shapes and add them together. So if you look at shape A now, The height is 4 meters. If you look at it here, this is 4. And the breadth is 1. So area of the triangle is half base times height. We're going to do half times the base, which is 4, times the height, which is 1. 2 and 4. So should I give us 2 times 1? That's 2 meters. That's for the triangle. Now the rectangle, the trapezium, you have to be very careful. You have to change the direction of the shape. This is how a trapezium should look like. The formula for area of a trapezium is half A plus B, then H. So if you change it like this, you know before the trapezium was like this before, from this shape. So we have to change it so that it will slant like this. This will be your A, this will be your B, and this will be your height. So this place is your A, and it's 6. From here to here is 6, then from here to here is 4. So we say half 6 plus 4. Then our height is this base, which is still 1. So 6 times plus 4 is 10. Divide by 2, that's 5. 5 times 1, that's 5 meters. C is the rectangle. And this is how a rectangle looks like. The area of a rectangle is length times breadth. The length is 2.53, 3.5 times. So 6 times 5, 30, 0, 3. 6 times 3, 18. 18 plus 3, that's 21. 21 meters. And this last guy is a triangle. Area of a triangle is half base times height. The base is 0.5 and half times 0.5 times the height is from 2 to 6, which is 4. So 2 here, 1, 2 in 4, that's 2. Times 0.5, that's 1 meters. So we add 21 plus 1 plus 5 plus 2. That's 21, 22, 24, 29 meters. The closest answer is D. Absolutely. But the reason why we could not get such an accurate answer was because we can't say exactly the journey, how the journey traveled. If you look at this now, I mean, what I can see is that it's traveled like this. It's not clear, like I can't even see. Do you understand? So that's why we could not get that accurate answer. But in the exam, it's going to be very, very accurate. You guys are going to see this diagram clearly. Do you understand? Is that correct? Okay. For question 2. Now, for question 2. 2 points on the velocity time graph have coordinates 5, 10, 20, 20 meters. Calculate the mean acceleration between the 2 points. It's very simple. Acceleration is change in velocity over time taken to make that change. The change in time as well. That makes sense. Now, you have 5, 10, 5 seconds, 10 meters per second. You have another point, 20 seconds, 20 meters per second. This is going to be a T1. This is going to be a V1. This is going to be a T2. This is going to be a V2. Do you understand? So you now do V2 minus V1 over T2 minus T1. So your V2 is 20, T1 is 10, over T2 is 20, T1 is 5. 20 minus 10, 10. 20 minus 5, 15. So if you have 5 here, 2, 5 here, 3. And that would be 0.67 meters per second square. Option A. Now this is clear. It's not clear. Okay. So the acceleration is velocity over time. But when we come to velocity time graph, acceleration can also be this formula. V2 minus V1 over T2 minus T1. You just have to decide on. So we have two coordinates, this point here. And we have this one. You just have to decide on which one do you want to make your V1 T1, then V2 T2. So I made this one 1, T1 V1. I made this one 2. And I've slotted it into the formula. V2 20 minus V1 10, 10 minus 10. Then T2 20 minus T1 5, 20 minus 5. So that gave me this value. It's just calculator. Question 3 says, the diagram below shows the velocity time graph representing the motion of a car. Find the total distance covered during the acceleration and retardation period of the motion. Find the total distance covered during the acceleration and retardation period. Okay, it's a very good one. So this one now we can apply the issue of the area now. Now this is the diagram. We have to calculate the total distance covered in this motion. Now, I already told you guys that the distance covered in a velocity time graph is the area of the shape formed. So if you can get the area of this shape, you are going to get your answer. Now, for this question, you can use two formulas. The first method is the simplest and easiest one, is to think of this guy as a trapezium, then solve it using the formula for area of a trapezium. The area of a trapezium is half A plus B, then H. So this place will be your A. So for this question here, you can use this formula for area of a trapezium straight. So this is going to be your A, and everything here will be your B, and this will be your height. So from here to here is from 10 to 40, which is 30. So your A is 30. Then the whole of your B is from 0 to, this is looking like 45. And your height is from 0 to 10. So we just use the formula half into A, 30, plus B, 45, multiplied by H, which is 10. 2 year 1, 20, 10, 5. 30 plus 45, 75 times 5. Sorry, 75 times 5. 375 meters. Option G. 375 meters. So that's one method to do it. Another method that you can try is find the area of a triangle here, half base times height. Find the area of a rectangle here, length times breadth. Then area of a triangle here, half base times height. Then you add the three together. This half base times height here will give you half times the base is 10 times the height is 10. So 2 year 1, 2 in 10, 5. 5 times 10, that's 50 meters. So this place is 50 meters. This place is length times breadth. From here to here, 10 to 40, that's 30, times breadth, 10, that's 300. And this place to have base times height, half times your base is from 4 to 45, that's 5, times your height is 10. So here 1, 2 and 10, 5. So here is 25. If you add the three together, you get what? 375, which is still the same thing. Is that correct? Now, for question 4, it says, a stone thrown vertically upwards returns to the ground. Which of the following figures represent the velocity time graph? For question 4, I want you guys to think and send the answers. You can only see C. The question says, the stone thrown vertically upwards return to the ground. Which of the following figure represents the velocity time graph? Option D. Option D. Okay, someone shows option C. Can you tell us the reason? Can you type in the chat box the reason why you think it's option C? And you that you pick option D, can you tell us the reason why it's option D? Okay, so let's analyze all the options so you guys can have a good idea of. I shouldn't have started with this question so that it will not confuse you guys, but I don't have a choice. Let's just start with it. Now, a stone thrown vertically upwards. So the stone is thrown upwards. Now you know upward motion. It's not projectile motion and it's not inclined at a particular angle. So it is just vertical motion. So a stone thrown vertically upwards, we throw it upwards. It gets to a maximum height and it comes down. That's what happens. So a stone thrown vertically upwards returns to the ground. Which of the following figures represent the velocity time graph? So why is option A not correct? Option A and B, option A and C are not correct because of the same reason. They started from rest. A stone that is thrown upward does not start from rest. No, lie. Do you understand? A stone that is thrown vertically upward is thrown with a particular velocity. That's why you cannot leave the stone and the stone will go by itself. Possible. We talked about that in the last class. So option A and C are wrong for that reason. They started from rest. So our answer is between B and D. Do you understand? So option A and C are wrong because they started from rest. The question says the stone is thrown vertically upward. For you to throw it, you have to throw it with a particular velocity. You cannot leave it at the ground and it will go up by itself. It's not possible. It is only in India movie that it is possible. But normally, you cannot leave something and it will go up. It's not possible. Do you understand? So if you look at option A, the velocity is increasing linearly. And once it gets to a particular point, it just comes down and go back to zero. Do you understand? If you look at option C, it's a parabola, giving us an idea that it's a projector. You can see that Benny Becker said he chose the option C because he thought it was a projector. So it's a curve shape, a parabola. And you see that the velocity rises and falls smoothly. Happy? Good. So the reason this is wrong is because it started from zero, and also it is a curve. The graph is supposed to be a curve. Now let's come to option B. Option B started from a particular point. Means that it has a velocity, only velocity. The same thing here too. D. It started from a particular velocity, maybe 20 or 50. Asha just okay at the fact we chew it up with a particular what velocity. So you can see from the graph that started from what? From a particular velocity, right? And the velocity is positive. That's what we want. We want this to start from a positive velocity. Now, it keeps going, 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 going until it gets to a particular point whereby it stops. That point where it stops is the point where the velocity is going to be zero. And that's this point. This point here. So these two graphs are correct up to this point. Up to this point. Now, the argument now is when the object is thrown up and it gets to a particular velocity and it comes down, that's coming down. Does it make the velocity negative? That's the question now. That's coming down. Does it make the velocity negative? This graph here is telling us that the graph comes to zero. And again, the graph, the object started from a particular velocity that we treat it with yes. It comes to rest. And again, it suddenly goes up. The velocity increased again. Is that the case? Or it started from a particular velocity that we threw it with. It came to rest, and the velocity starts reducing again. It came to rest, and the velocity starts reducing again. Which one is correct? That's the argument, too. I hope you understand the point we are now. Did you guys thought about what I just said now? Did you think about it? I just mentioned some things that are very, very important. Did you think about it? Or should I explain again? One. Between the argument is between two graphs. Graph A. Now, it does some velocity 20 meters per second. Kilometer. The speed stops and the object comes down to that plane where we threw it. Now, because this object was thrown with particular velocity, remember that this velocity and started reducing. It gets to zero. That's how we do that. Say the 20. This is zero again. 20, 0. Now, and now start down again. Say is it better now? Can you hear me now? Good. Now, the argument now is when this object, the object started from 20 meters per second, it keeps going up until the velocity gets to 0. then the object starts coming down. This coming down now, do we say that the velocity is negative, or the velocity has also increased again? Do you understand me? The most correct thing is, because it is moving in the reverse direction, the most correct thing for us to say is that it is moving in the opposite direction. And when we know in physics that when we work with opposite direction, it means that we are going to reverse the what? The sign. So we say that the velocity is what? Is negative. So the correct answer to this question is option D. I hope you understand. If you check Jam Remix, they didn't pick option D. But this question, I'm still going to make more findings on it. What is most correct to me right now is that option D is the correct answer, not B. Do you understand? And I ruled out the reason why A and C are not correct. But I would go with option D. At this present moment I'm talking to you, I will go with option D. Because when we say that the direction, when we reverse direction, because it is still the same direction, something started from 20 and goes up to 0. Because we know that that object cannot stay in the air, it has to come down. It will come down along that same path. Now, in the opposite direction, when you up, even in momentum, when we say they are moving in opposite direction, what do? We put minus for one. So it means that that other one is moving in what? And it's actually velocity in the opposite direction. It's not the mass that is negative. It is the what? The velocity. Do you understand? So what is most correct to me at the moment is that what? Option D is the correct answer. Do you get it? Do you understand? Everybody. Lawal Rodia and Lawal Rafia, those guys are twins. And those guys are doing excellently well in my class. Are you guys from Ocean State? No. Don't worry. We need to talk. But I want you guys to take my test first before I know if I want to talk to you or not. Okay, let's come here. The diagram below shows the velocity time graph of a vehicle. Its acceleration and retardation respectively are. Let's zoom in. Don't worry. You'll be able to see the question correctly from your own end on the day of your exam. So don't be scared that, my question, I didn't know. You will not see it like this. I'm so certain. From my past question, I can see this place as 80. So let me confirm from Jam Bremex if it's 80, so that we'll not just waste time solving. 1999 question 7. 1999 question 7. Yes, it is 80. Yes, so we can work with it. Now, I already told you guys that acceleration and retardation are different. The only place we have acceleration here is this place. And where we have retardation is this place. Once to back burn is okay by is acceleration. To back burn wale is retardation. To buy by no acceleration. This one is acceleration. This one is no acceleration. This one is here. Another reason to note that if you alternate the sign, the direction, the sign will be negative. Is that this one here is acceleration. This one is negative acceleration. Can you see? We are going like this. We are coming like this. Can you see that? That's another reason why I would also pick option D as my answer again. You can see everything is buttressing this option D as my answer. It will go into the negative. That's why this velocity is going into the negative. Not that the velocity will increase. This one is saying that the velocity will increase again. And look at it. It has even almost gotten to the same level of what it started with. How now? So it is subject to what? To a lot of discrepancies. So the most correct answer is option D. To me. Because I know most of you guys are scholars. You might have read some things that is different from what I said. If you know have a contrary opinion, you can tell me. Let's discuss with physics mind. Nobody's an island of knowledge. I don't know it all. Now, the diagram below shows the velocity time graph. Its acceleration and retardation respectively are. So where do we have acceleration? Do you have retardation? No, don't stress yourself. Just come here. Do 80 minus 0. Let me change this ink. It's too big. Do for acceleration, do 80 minus 0 over 20 minus 0. Why did I do that? I picked 2 points. This point here is 80, 10, 80, 20. Yes. And this point here is 0, 0. So that will be 80 over 20, which will be 4 meters per second square. That's acceleration. Then retardation now will be this point here. Pick this point and this point. This point here will be 80 minus, sorry, 0 minus 80 over, this is, what's this point? 90, is it 90? Yes, 90. 40. Okay, from here to here, 90 minus 50. So that will be negative 80 over 40. That will be 2 meters, sorry, 2 meters per second square minus. The negative because it is what? Retardation, but it doesn't really count. That's why it doesn't really count. This negative here also does not really count. Do you understand? But in the graph, it counts because it's movement. Do you understand? But in value, because you might be telling yourself that should speed legend negative only negative more because it is what? It is vector quantity. Do you understand? Can be negative. That. So the value is 4,2. So that's 4, 2. Option C. So here it says, what is the acceleration between 2 points on a velocity time graph which has a coordinate of 10 seconds, 15 meters per second, 20, 35. So just pick, it is 10 seconds, 15 meters per second. Let me use it. 10 seconds, 15 meters per second, and 20 seconds, 35 meters per second. So just do 35 minus 15 over 20 minus 10. You can see the meter per seconds. I subtracted the meter per seconds, 35 and 15, and I subtracted the seconds, 20 and 10. So that will give me 35 minus that's 20 over 10, which is 2 meters per second square. Option D. Is that correct? Question 7. The diagram below shows a velocity time graph. The statement that is true about this motion is that the car A decelerates between point F and H. Point F and H is not just deceleration. From F to G is constant first. No acceleration. Then G to H is deceleration. So if you now say F to H is deceleration, you are wrong. Accelerate between point F and G. Point F and G, there's no acceleration. So that one is also wrong. Point C has a constant speed. Has a constant speed between points E and F. E and F, constant speed. No, the speed is not constant. The speed is increasing as the time is increasing. D has no acceleration between F and G. That's the correct answer. Option D has no acceleration between point F and G. If you don't understand this one, you have to go back to last class because I explained it in the last class. Question 8. From the velocity time graph shown below, which of the following quantities cannot be determined? I love jam is so sweet. So sweet. If you sabi, you sabi. If you know sabi, you know sabi. From the velocity time graph shown below, which of the following quantities cannot be determined? We can determine deceleration. We can determine initial speed. We cannot determine acceleration. That's what we cannot determine because there's no acceleration here. The only thing we have is what? Deceleration. We have deceleration, yes. We have initial velocity. We have total distance traveled, yes. Now shape. This is rectangle plus triangle, so we can determine the total distance traveled. But we cannot determine initial acceleration. No, there's no acceleration here. Acceleration must be like this. If there's no line like this, there's no acceleration, my sister and brothers. Is that clear? Jam want to know that thing that your teacher explained to you. That's what I taught you. Yeah, I'm a shape. I'm a for one class. Do you really understand it? Jam want to test you on that one. From the diagram below, the region of zero acceleration is. Everybody type it. Let it go. Let it go. The region of zero acceleration. That's the region of no acceleration. The acceleration, that's why it is going up. The acceleration here again, that's why it is going up. There's deceleration here, that's why it is coming down. Where there's no acceleration is NS. And that's option B. If you don't understand, you have to go back to last week's video. I have made the videos so simple for you guys. I have shared each of the videos playlists. The mathematics that we did today, don't stress yourself. Just go to the YouTube video and check under mathematics. You are going to see all the videos that we have made on mathematics. So the last video, I have numbered it. Today's video now would most likely be number 7 or number 6, either of the two. So which of the following graphs represents motion with uniform velocity? This question too, your bum will come out. Answer please. Uniform velocity. If I say your bum will come out, it means the BMI your. You know when somebody's bum come out, that's when they have dirty. Uniform velocity. Uniform velocity. I can see answers and I am happy that I have taught you guys. I am happy that I taught you guys. I can see answers and I'm happy. People are already sending the answers. People are already sending answers and I am happy that I taught you guys. I am so happy. Where do we have uniform velocities? Option S. Is there an option like option S? There's no option S there. I see S. What's S? I don't understand S. D. Okay, D. I see means D. Uniform velocity. Uniform velocity. Uniform velocity. Question 10. I am so happy. I'm the happiest person on earth. Option. Okay. We have seen enough of options, and I'm happy that 2 people got it right. Amidat Dosumu and Benny Beko, you got it right. So if you pick other than option B, you are wrong. Now, Jam already set a trap for you here in this question. This question, they set a trap for you. They confuse velocity time and displacement time. This one is velocity time. Even if you cannot see it clearly. Even if you cannot see it clearly, look at it. Velocity time. But this one is displacement time. Displacement time. Can you see it? It is different, totally different. Velocity time and displacement time are different. I already told you guys, look at the graph before you pick your option. Now, this one is acceleration graph. This one is velocity graph. I told you that velocity time graph is talking about acceleration. Displacement time is talking about what? Velocity. So this one here is uniform deceleration. It's wrong. This one here is uniform acceleration. It's wrong. The question wants uniform velocity. This is where you have uniform velocity. This place you have constant velocities. Can you see velocity acceleration displacement time? So the question 11. The velocity time graph of the body moving in a straight line and decelerating uniformly to rest is represented by, you have to be very careful, it is two graphs at the same time, moving in a straight line and decelerating uniformly to rest. Question 11, what's your answer? That straight line is telling you that it is what? It is a rectilinear motion, but it is decelerating to rest. Which one is deceleration? C. Deceleration is C. It's correct. Excellent. 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 C. Excellent. C. When we see this curve, we'll talk about them. For now, no. This one is, you can see, this one is acceleration. Question 12. Which of the following, which of the velocity time graph shows uniform acceleration of the body from rest? You can see this one too. Very simple. Now, I don't give you very, why is exam going so simple like this? Uniform acceleration. So I hope you guys checked there is this velocity time graph. You see velocity meter per second. Although it's not very clear, but let's manage it like that. What is the acceleration of a particle whose motion is graphically displayed in the figure below? Now, look at the start point here. This point here, it is 2, 0. Sorry, let's say 0. If you take 6 penalties, so just take the nearest one. So 2 minus 5 by 6 over 3 that's 0.67. Option A. Do you understand how I did it? Just pick 2 points. I said you're working on graph and find the slope. The slope of the velocity time graph is what? Is acceleration. I said it. The slope of a displacement time graph is what? Velocity. I said it too. In fact, let me come here so I can show you guys. So I would not say I. You did not say it. You did not say it because students are very funny. They will start saying that I did not say it. The slope of a distance time graph is, can you see? Slope of it. It's not even perfect. So I said it, you. So what I just did here is just to find the slope. I pick one point here and I label this point 0, 2. I pick another point here. But because it's very close to 6, I say let me pick 6, 6. This might have been it might have been graph error. So it's not 8, so I cannot pick 8. What makes sense for me to pick is to pick 6 minus 2 over 6 minus 0. So this is your time velocity, VV, CT. Do you understand? Question 14. I have solved this question. Solve. I'm tired of solving this question. Two taxis leave Benin and Agbo some 80 kilometers apart at 1200 hours from the distance time graph shown below. The distance of their meeting point P from Benin and the time of their meeting are. Who wants to try it? Question 14. Let's give 1 minute. Let's see who can think about it. 1 minute. That's what you expected to spend on the question. Just 1 minute. So two taxis leave Benin. So this is Benin here, and this is Agboye. Some 80, so Benin and Agboye are 80 kilometers apart. Can you see? At 200 hours. So they started at this hour, 200 hours. From the distance time graph shown below, the distance of their meeting point P from Benin and the time are, so this point here, just trace. That's what I think that's what you're supposed to do, just trace, tracing. So you're supposed to trace and also trace down. Abi? That's what you're expected to do. But how do we know what is accurate? Wow. 20, 30 kilometers, 40. So we need something that is very close to 30 kilometers. So we can see 27, 29. It can be C, it can be D. Good. Now, time now. Let's come down. We have 1 hour, 2 hours, 3 hours. This is going to be 1.5 hours. 1.5. This is like half of it. The most correct answer is going to be B. If you pick A, what's the justification for picking A? This question is just tracing question. No? It's not, there's nothing serious here. There's no calculation at all. It's just tracing. So here is 1,200. You know anything you get, you're going to add it to 1,200. So 1,200 to 1,500 hours. That's how I got my own 1200 and 150. But the most probable answer is going to be option B. It's just tracing question. And most likely you're going to get something even better. So question 15, you can see all these ones are already questions. They give you very graph, something that you can trace properly. So the distance traveled by a particular, sorry, the distance traveled by a particle starting from rest is plotted against the square of the time elapsed. From the commencement of motion, the resulting graph is linear. The slope of this graph is A, is a measure of A, initial distance, displacement, initial velocity, acceleration of the acceleration. Question 15, I want to think about it. Distance traveled by a particle starting from rest is plotted against the square of the time elapsed. So you have something like this. Distance over c squared. The resulting graph is linear. So we got a linear graph. Either like this, or like this, or like this. It's linear. The slope of this graph is a measure of. Yeah, think. Maybe I can think. Yeah, now who can think and tell me this answer? Who can think and tell me this answer? They're asking you for formula. I want someone that can give me that can tell me and think about this question. I'm going to give that person something. I promise. Now, okay, that should be like this. I want someone that can think and tell me the answer. Oh, yeah, now, let us this time. Now, the distance traveled by a particle starting from rest. So the particle started from rest. Now, let's look at something together. Someone said B. Let's look at something together. Distance traveled by a particle starting from rest. Distance. Abi? So let's use S. S unknown. A particle started from rest, U is 0. Abi? Is plotted against the square of the time elapsed. T squared. Does this look like something that you know? SUT squared. The formula that has SUT squared. That formula is S is equals to UT plus half AT squared, right? Because U is 0, this one is already 0. So S is equals to half AT squared. Abi? Now, they now plotted this distance S against T squared. Abi? Plotted against the square of time. They are now asked to find the slope. What is slope? Slope is divide by T squared, divide by T squared. The slope is going to be S over T squared, which is what? Half of acceleration. And that's the answer, option D. Half the acceleration. So I said if you get the answer with a proof why it is correct. So question 15, the answer is D. Now question 16. The figure below shows the displacement time graph for 3 different motions. Which of the following statement is correct? Graph 2 corresponds to the highest velocity. Don't forget, it is displacement time. Graph 2 corresponds to the highest velocity. Graph 2 on the highest velocity. Okay. Graph 1 corresponds to zero velocity. Graph 1 only corresponds to zero velocity. Graph 3 corresponds to a particle moving in negative x direction. Graph 3, particle moving negative. Graph 2 corresponds to a particle moving in the positive x direction. So which is the answer? Graph 16. Which is the answer? So the correct option is that graph 1 corresponds to zero velocity. The same thing as applicable to acceleration time graph, applicable to what velocity time graph. Do you understand? So graph 1 corresponds to zero velocity. Just know that for velocity time graph, what we are talking about is acceleration. For displacement time, what we are talking about is velocity. So in velocity time graph, if it go like this, there's acceleration. If it comes like this, there's no acceleration. If it comes like this, there's retardation. For velocity time, for displacement time, if it comes like this, there's uniform velocity. If it comes like this, there's no velocity, and if it comes down, there's what? Negative velocity. Do you understand? Negative velocity. Or the velocity is reducing with time. Do you understand? Let's say it that way. So B is the correct answer. Yeah, question 17. How is the total distance covered in the stages of motion represented by the diagram above? Very simple. Calculate the distance here. Calculate the distance here. Area. Yeah, it will just be 10 times 5. So it is 50 here. Yeah, it will just be half base times height. That's half times 5 to 8 is 3. Then the height is 10. So 2 here, 1, 2 in 10, 5, 5 times 3, 15. So 15 plus 50, that's 45. So there's a mistake somewhere. Where? 5 times 10, 50. Then 5 to 8. Check 20, 17.5. Is the value looks correct? Half base times height. Half base is 3. Height is 10. 2017. Bab. Bab 2017. Okay. So the answer I got is 45 meters. I don't know what happens. The distance covered in the stages of motion above. Okay. Let's come in. So, yeah, we have just 7 questions and we are done. Let's quickly finish before I don't want to I don't want to come back to this jargon's topic. Talk. Let's cross. A ball is thrown vertically into the air with an initial velocity u. What is the greatest height reached? In fact, I think I gave you guys the formula. So if you don't know it, that means that you need to go back to the last class. Under projector. I remember talking about it. No, under yes. Time to get greatest height reached is u squared over 2g. Time to get to maximum height is u over g. You can see that. Let's asking you for the formula. U squared over 2g. So that question is very simple. You know what you're doing. U squared over 2g from d. Two bodies x and y are projected on the same horizontal plane with the same initial velocity, but at angles 30 and 60 respectively. The ratio of the range of x to that of y is what do you do? You have to calculate the range individually. Is that what you do? Yeah. So once you calculate the range at theta 30, then the range at theta 6. What's the formula for range? R is equal to u squared sine 2 theta over g. U squared sine 2 theta over g. Someone should calculate the range at and tell us the answer. Yeah, yeah. Let me solve it before you tell me that because our time is past spent. We don't know if tomorrow will be Ramadan day 1 or not. So everybody's waiting for Sultan. So R is equal to U squared sine theta over g, with the same initial speed. So the initial speed is not relevant. In fact, this question, you don't need to solve anything. It only says the ratio of the range, right? These are the same. So we can cancel it out. This will be the same for both of them. We can cancel it out. So what is important is only this guy, sine 2 theta. So for the first one, it will be sine 2 times 30. 1 theta is 30. The second one, it will be sine 2 times 60. So here it will be sine 60 versus sine 120. What is sine 60, guys? Sine 60 is the same thing as sine 120. They are the same thing. If you press your calculator, let's use the expo first. I know that you guys don't have sine calculator that has sine. I'll only tell you the scope when you come to math class. So where is my iPad calculator? iPad. Sine 60, 0.8660, sine 120, 0.8660. So when you come to math class, you will know why and how they are the same. But if you have gone to a very good secondary school, they will have taught you something like quadrants. And in quadrants, you can get whatever angle you are looking for. So sine 60 and sine 120 are the same. Those of you that are not math students, you have to come here. You have to attend math class. So it's important. Just come. Just do freestyle. There are some things that you need in physics that is math based, like this one now. So sine 60 is 0.8660. Sine 120 is 0.8660. So they are the same thing, 1:1. That's the answer, option A. A shooter wants to fire a bullet in such a way that its horizontal range is equal to 3 times its maximum height. I love this question. I have solved it countless times. A shooter wants to fire a bullet in such a way that the horizontal range is 3 times the maximum height. At what angle should he fire the bullet to achieve this? So I've given you what you need. Just put formula. Range, you have formula for range already. Greatest height, u squared sine squared theta over 2g. So that you not forget this formula. Greatest height is the only one that has square square 2. Square square 2. So u squared sine squared theta over 2g. Range, that one does not have sine square, it has sine 2 theta. You can see that I'm multiplying the theta with 2. I didn't square it, unlike sine square theta. Yeah, quickly, question 3. So that you guys do not slow me down. Let me solve. Now, B. Okay, let me show you guys. Now, my range is u squared sine 2 theta over g is equals to 3 u squared sine squared theta over 2g. So let's cross multiply. So we have 2g u squared sine 2 theta is equals to 3g u squared sine squared theta. Now, g cancels g, u squared cancels u squared. I'm left with 2 sine 2 theta is equals to sine squared theta. Now, if you are a very good student,
Sir, you skip the 3.
Atiya, thank you. If you're a very good student and you know how this sine 2 theta came about, there's something called double angle in further mathematics. It's not math, so it's in further maths. You see this sine 2 theta? It's the same thing as 2 sine theta cos theta. 2 sine theta theta. So I'm going to change to 2 times sine theta. I will change it to this. 2 sine theta cos theta is equals to 3 sine square theta. So now sine theta can cancel one of this square. So we have 4 cos theta is equals to 3 sine theta. Now let's put the numbers together. Divide here by 3. Divided by 3. So divided by cos theta, divided by cos theta. So this cancels this. So I have 4 over 3 is equals to sine theta over cos theta. Now, sine theta over cos theta in trigonometry ratio is tan. Sine theta over cos theta is tan. So I have 4 over theta, 3 is equals to tan theta. Now, if we take the do the decimal form of 4 over 3, divide by let's come here, or divide by 3 gives us what? 1.33333. Now let's do ANAC 1.333. Can you see that the answer is 53.1? But how can you get tan arc on your exam day? There's no how you can get it. So theta is actually 53 degrees, which is the option here. But how can you get this tan? How can you get it? That's going to be 53 degrees. There is a way. And the only way is that you have to know your special angle. That's the only way. So when we are doing trigonometry, that class is very important. I'm going to ask you guys, physics class, to join the class. Do you understand? I will tell you that it can be 68. It can be 30, because if it's 30, can already has its value for 30. It can be 45 also. So the fight is between 23 and 68. So you now have to use the value of tan 60. Tan 60 is a special angle. Special angle of what? Of sine 60 over cos 60. That's how you have to think about it. Tan 60 will give you sine 60 over cos 60. Now, sine 60 is 0.8660. Cos 60 is 0.5. So when you do this guy, 0.8660 divided by 0.5, you can see that it is far from 1.333 that we got. So the answer is going to be far from 60. Do you understand? So that's the only intuition you can use to know that the answer is going to be 53 and not 60. It's not close to 60. Do you understand? Now, question 4. Place five outside upward from a gun held 2 meters above the ground, which is maximum height in 4. You guys should go and practice this 4 remaining question. Question 4, 5, 6, 7. Let's stop here. We hope they see the moon today so that we can start tomorrow. And if not, the rest tomorrow again, we'll start. Thank you so much, guys.